Hello everyone, my name's Adam. And in this problem, we're going to be verifying the identity 1 plus sine theta divided by cosine theta plus cosine theta divided by 1 plus sine theta is equal to 2 times secant theta. Now again, when verifying identities, what we're fundamentally trying to do is show that one side of the equation is equal to the other. Now the general rule of thumb is to take the more complicated side of the equation and start working with that, which I think we can see as the left-hand side. So we're going to take our left-hand side, (1 plus sine theta divided by cosine theta plus cosine theta divided by 1 plus sine theta. So what we have is an addition here, and we want to combine these two things. So we combine them by coming up with a least common denominator, which is going to be the product of the two separate denominators. And we arrive there by multiplying our left and right, say by the respective denominators. So cosine theta is going to be multiplied on our right as cosine theta over cosine theta. And on our left, we're going to multiply 1 plus sine theta over 1 plus sine theta. So what we get is the expression with the common denominator of 1 plus sine theta times cosine theta, and our numerator is going to be the product 1 plus sine theta times 1 plus sine theta plus cosine squared theta. Okay. So we want to continue to simplify this, and in the end, hopefully we get something equal to 2 cosecant theta. Now, we have fundamental trig identities that we can use, but before we go there, we're going to do some algebraic simplification in the numerator. So namely, I'm going to multiply this term out, 1 plus sine theta times 1 plus sine theta, added with cosine squared theta, and see what we can go from there. So again, the denominator, 1 plus sine theta times cosine theta, and our numerator, just foiling out, 1 times 1 is 1, plus 1 times sine theta and sine theta times 1, or 2 sine theta, plus sine times sine, or sine squared theta, and plus cosine squared theta. Now, algebraically, what we would first look at is can we combine anything, mainly looking at common terms. But we don't have that. We have 1 plus 2 sine theta plus sine squared theta plus cosine squared theta. So now is when we're going to look at using any fundamental trig identities that we could possibly bring into play. So looking at this, well, we see sine squared and cosine squared. And we know that we have a trig identity dealing with just that, namely the Pythagorean identity, sine squared theta plus cosine squared theta equals 1. So this entire expression here, sine squared plus cosine squared, is equal to the value 1. So what we're going to have is 1 plus 1 in our numerator would give us 2 plus 2 sine theta. And again, all divided by 1 plus sine theta times cosine theta. Now we can't simplify the numerator anymore, but what we want to see is can now we simplify by factoring and maybe canceling out things in the numerator and denominator. So if we look at the top, we have 2 plus 2 sine theta, which if I factor out a 2 would give me a term 1 plus sine theta, which could be canceled out. So that's what we're going to do. So we're going to factor out a 2 in our numerator, and we'll bring that all the way to the outside. So we're going to have 2 times 1 plus sine theta over 1 plus sine theta times cosine theta, which, like we said, the 1 plus sine theta will cancel out. come up over here. So leaving us with 2 times 1 over cosine theta. Now 1 over cosine theta can be simplified if we use our identity. Secant theta is 1 over cosine theta. So 1 over cosine theta can be written as 2 times secant theta, right? Which verifies our identity. So 1 plus sine theta divided by cosine theta plus cosine theta divided by 1 plus sine theta is equal to 2 secant theta. Now we're going to use the table feature of a graphing utility to check our result numerically. So what we're going to do to show that we've verified the identity that 1 plus sine theta divided by cosine theta plus cosine theta divided by 1 plus sine theta is equal to 2 secant theta is we're going to enter in each side of the equation as a separate function. And in the table feature, for given angle values, we'll see that both function values are equal to each other. So we'll get started by going into our equation input and entering as our y1 equation, the left-hand side. Now instead of theta, we're going to be using the value of x. We're going to type in parentheses the quantity 1 plus sine of x divided by cosine of x plus cosine of x divided by the quantity 1 plus sine of x. And then arrow down for our second equation, we have 2 secant of x. But secant being 1 over cosine, we'll type in 2 divided by cosine. Now before we go to the table, we're going to do our table set feature. And wherever we want the table to start, whichever angle, it's really arbitrary. But we'll just say starting at 0. And delta table, we can just have it counting by 1. Now we're going to do this in radians, but it really doesn't matter either it's radians or degrees. We'll see that because the identity matches, that both function values will be equal regardless of what we have. So we'll take 0 as our start, delta table as 1. And if you're not there, going into mode, making sure we're in radian mode. And lastly, going to our table feature, and we should see 3 columns. The x column is our values of x, or theta, the angle values. Our y1 is the left-hand side of the equation, and our y2 is the right-hand side of the equation. And we should see that all y values are equal to each other, verifying the identity. Thank you very much.